All right, welcome back to 6.5. We are moving on to solving rational equations. For the first 4 lessons in Unit 6, we were simplifying rational expressions, and today we are actually going to solve some rational equations, okay? So we're taking really just one step further, okay? It's not much different from simplifying, I'll be honest with you. Okay, so why don't you go ahead, try these 2 questions. These were just adding and subtracting rational expressions that we've done in the past. These 2 are monomials and these are trinomials. Okay, so give it a try. I'll show you the answer in a bit. Okay, so hopefully this is what you got. For the first one, this one is hopefully not too difficult. The common denominator would be 24x cubed. That's 6 and 8. So the lowest common multiple is 24. X squared and x cubed. X cubed would be the lowest common multiple for those 2. And you just need to multiply by for x here for the first fraction and multiply by 3 for the second fraction. Expand, combine like terms if you have any. Well, in this case we don't, and that is it. We cannot reduce this even further, so that's it. And x cannot equal to 0 is your restriction. For part B is slightly longer. You need to factor. Again, you should always factor first. Here you can factor the 3. Unfortunately, it didn't help us, but you know what? You should factor out just in case if it does help. For the denominator, you get x plus 5 and x plus 2. For the second fraction, you get x plus 5 and x minus 2. For the common denominator, remember these are not monomials, so these are polynomials. You need to actually multiply every single bracket, unless you have common ones already, right? So these 2, x plus 5, those are already common. So you just need one of them. You don't need 2 of them. You need x plus 2 there, and you need the x minus 2 there. So that's why I have those 2 here. For the first fraction, what we're missing here is x minus 2, so you gotta multiply by x minus 2. For the second fraction, what's missing is x plus 2, so you multiply by x plus 2 there. You expand, combine like terms, you end up with this expression right here. Now I remember I mentioned this to you that your final step is to check whether numerator could be factored or not. In this case, it's definitely factorable. You actually get 3x plus 2 and x plus 5. And notice x plus 5, they are the same. They can actually cancel out. So this is what you end up with at the end. And that's your final answer, okay? So like I said, you should always check if this is factorable or not. Sometimes it's factorable and you can actually do something with it. The restrictions will be plus minus 2 and negative 5. Okay, so this is what we did the last 2 lessons. Okay, now we're going to move on to solving rational equations. Okay, so just like when you're adding and subtracting rational expressions, you needed the common denominator. In this case, we also look for the common denominator. Okay, so again, it's not that much different from simplifying. The steps that you take, the first step at least is the same. You look for the common denominator. In this case, it is 10x. Now, what you do differently though is, in this case, you actually multiply every single term by 10x. Okay, you multiply every single term by 10x. So you go 1 over 2x times 10x. I'll do here on the side and I'll show you what that does, okay? When you do this, remember you can cross out the x's. You can reduce the 2 and the 10 by dividing both numbers by 5 or by 2. You get a 5 there. So this 1 over 2x times 10x actually end up with a 5. For the second term, you get 2 over 5 times 10x over 1. Same thing. You can cross out these 2 by dividing both numbers by 5. You get 2 times 2x, which is 4x. And you have 1 over 10x times 10x. You can just simply cross out the 10x's. So you actually just end up with 1. So you can see you actually end up with a linear equation like this. This is something that's easy to solve. We can move all the numbers to one side and divide both numbers by negative 4, you get 1. And you should always check your restrictions, because sometimes we do end up with no solutions because extraneous roots, okay, because they conflict, right? Your answer and the restriction, they are the same, but in that case, your answer will be no solution. In this case, x cannot equal to 0, so we are okay. They are not the same, so we're fine. Okay, I will do part C and I'll let you do B and D. So part C, same thing. We need to multiply by the common denominator. In this case, it's because it's binomial, so the common denominator is actually x minus 5 and x minus 1. So when you multiply, what happened is you cross these two out. So you multiply x plus 2 with x minus 1. Right? And for the second fraction, these two will actually cancel out. So then this side you end up with x. Don't forget the x minus 5 though, okay? The x minus 5 cancels with this one, but it's brand new now, right? You don't cross it out and it just disappears for the second fraction as well, right? Okay, so here is what you got, and now this is looks like it appears to be a quadratic equation. Well, we just need to expand. You should get x squared plus x minus 2. That's what you get when you expand the left hand side. On the right, you get x squared minus 5x. Recall, for solving quadratic equations, you need to make it equal to 0. So I'm going to move everything to one side. Now, however, notice if you move the x squared to the left, they just disappeared, both of them. So this actually is a linear equation. So now, solving linear equation is different from quadratic equation. Linear equations, you need to isolate for x. So I'm going to move the 1x over here to the right, and I get negative 6x. Now I can divide both sides by negative 6. I get negative 2 out of negative 6, which is actually 1 out of 3. Now we check the restriction. In this case, x cannot equal to 5, and x cannot equal to 1. And our answer is 1 over 3, which does not, again, conflict with our restriction here. So we are fine. Okay, you can try part B and part D. Let me just give you a heads up. Part B, you end up with a quadratic equation, and it's not factorable. Okay, so don't think that you made a mistake. It's just not factorable. So I guess you need to use quadratic formula. Okay, so give it a try, and I'll show you the answer in a bit. Good luck. Okay, so for part B, you need to multiply by the common denominator, which is x squared. And this is what you get after you multiply with every term, again, every single term with x squared. This is what you get. It's quadratic equation, so you got to make it equal to 0. Again, you will notice that this is not factorable. Therefore, you need to, I guess some people ask me, how do you tell if it's factorable or not? What you do is you multiply 6 with negative 6, you get negative 36. You think of two numbers multiplied to negative 36, and these two numbers add to negative 25, which is the middle term. If there is no such combination, then it's definitely not factorable. If there is a combination that this will work, then it's factorable. This one is not factorable. Okay, nothing multiplied to negative 36 and add those two numbers add to negative 25. That's just not possible. Therefore, you need to use quadratic formula, and this is what you should get. And because, again, you check with the restriction, x cannot equal to 0. Well, none of these two are equal to 0, so we are fine, okay? For part D, same thing. You should always factor first, okay? So some of you may think that the common denominator is this. Yeah, don't do that, okay? Because then in that case, for the right-hand side, you end up with a cubic function, which we haven't learned yet, okay? So factor, you get x plus 3 and x minus 3. So then you'll see that the common denominator is actually just x plus 3 times x minus 3. Same thing, carry out the procedure. You should get a quadratic equation like this. And you get this is factorable. You get x equals to 3 only. However, if you check the restriction, you'll see that x cannot equal to plus minus 3. Therefore, again, they conflict with each other. So in that case, there's no solution, okay? Again, the restriction trumps the answer that you got here, because, well, x just cannot equal to 3. Because if x is 3, then that's 0. You can't divide it by 0. This is also going to be a 0. Okay, that's why there's no solution here. All right. Here we go. Hopefully this is not too bad for you. Okay, so again, the procedures, the steps actually is written down over here. You need to first find the LCD. Okay, and then you need to multiply both sides, every single term, okay, every single term by the LCD. And then you remove the bracket by multiplying, combine like terms, and then solve the linear or quadratic equation that you have. You should always check the solution, because, you know, sometimes you could make a mistake, and on the test you'll have time, so check your answers always. All right, I will do Oh, fine, I'll do one for you, and then I'll let you try the other one yourself. It's really the same thing, okay? It just looks longer. It's the same thing. First step, always factor if possible, and definitely we can factor the last fraction over there. And this is going to be x plus 6 times x plus 4. You still have the 11x plus 32 over there. So now, once you have it factored, you can actually multiply by the lowest common multiple, which is going to be x plus 6 times x plus 4. Okay, so this is your lowest common denominator. And now you can actually multiply and then get rid of all the denominators. So you have x plus 6 here, but you're multiplying with x plus 6 and x plus 4. So the x plus 6's will cancel out. You end up with x plus 1 times x plus 4. For the second fraction, you have x plus 4 here, but you're multiplying again with x plus 6 and x plus 4. So once again, x plus 4 will cancel out with the x plus 4. So you'll need to multiply by x plus 6 with the x minus 2. For the last fraction, these two will just cancel out, so you just end up with 11x plus 32. Now we have got rid of the denominator, so now we just need to expand. This is going to be x squared plus 5x plus 4 plus x squared plus 4x minus 12 equals 11x plus 32. Now you can combine like terms. So this is going to be 2x squared plus 9x minus 8 equals 11x plus 32. You can move everything. This is a quadratic equation, so you have to move everything to one side and make it equal to 0. Okay. Now notice when you factor this, they are all multiple of 2's, so you can actually factor the 2 right away. Okay, to make the number smaller, you can divide both sides by 2. Then 0 divided by anything is 0, so these two really just disappeared. Okay, again, I have to be careful here, or you have to be careful here, but let me say this clearly. Okay, you can simply cross this two out if you're solving equations, because when you divide by 2, 0 divided by 2 is still 0, and 2 divided by 2, well, then it's 1, so then that 2 disappears. However, if you're simplifying, if this was an equation like this, okay, if this is what you got, you can't just say, oh, let me get rid of that 2 right there, okay? You can't do that, okay? You can only do it if it was an equation, because you're dividing both sides by 2, and, well, 0 divided by 2 is 0. So that 2 really is irrelevant. But if it was not an equation, that 2 is relevant, okay? So be careful. This is a common mistake that students make, so watch out for that. Okay, so now we can factor this. You get x minus 5 times x plus 4. This is equal to 0. Finally, x would equal to 5, or x equals negative 4. And now we just need to check with the restriction and see if we need to reject any of the answers. And it looks like we do, okay? In this case, our restrictions would be x cannot equal to negative 6, not negative 4, just those two. So cannot equal to negative 4 or negative 6. We have x minus 4 as one of the solutions, so you need to cross that one out and say that your only answer would be x equals 5. Okay, so step by step, it's just a little bit long. Okay, it's not that bad. It's only not even half of a page. Okay, good luck. Give it a try for the part B. Okay, I'll show you the answer in a bit. Okay, I will actually go over this question here from very beginning. Okay, so here, factor. So 3y minus 7. This is going to be y minus 3 and y minus 2 plus this is 3 minus y and 3 plus y. So because we have y minus 3 here, so what I'm going to do right now is actually I'm going to change this to plus and minus, and instead of plus sign here, I'm going to change it to a minus sign. Okay, then they are actually the same, okay, because we factor the negative 1 out here, and we put that negative 1 with this plus sign, they actually turn into a minus sign. So now when I factor negative 9 plus y squared, this is actually y minus 3 and y plus 3. We want this because this is y minus 3, and we want a y minus 3 instead of a 3 minus y. But again, you need to change the plus sign to now a minus sign. you still have the 2y plus 8. Now you could actually factor the 2, you'll get 2 times y plus 4, but it really doesn't help because you can't reduce it. So in this case, I'm not going to change it because again, it does not help in this case. Sometimes it does, not all the time though. You can factor this. This is y plus 3 times y minus 2. You have the y plus 2 over here. Okay, now we need to look for the common denominator. In this case, the common denominator is, we have, let's see, we have y minus 3, we have y minus 2, we have y plus 3, and I think that's all, right? Yes, that is all. Okay, so now we need to multiply again. Oh, sorry, I forgot to, this is equal to 0. Got too excited after all the factoring here. Equal to 0. Okay, now you need to multiply everything here by x minus, sorry, not x, y minus 3, y minus 2, and y plus 3. Okay, so for the first fraction, you have y minus 3 here and y minus 2 there. What's missing here is y plus 3, so you need to multiply 3y minus 7 with y plus 3, minus 2y plus 8. This time you have both y plus 3 and y minus 3 here, so that means this will left, right? Because these two will just cancel out. So 2y plus 8 needs to be multiplied by y minus 2. For the last fraction right here, you have y plus 3 and y minus 2. So the last two, these two will cancel out. Therefore, you would still need to multiply y plus 2 with y minus 3. 0 multiplied by anything is 0, so that one is easy. We'll just make it equal to 0. All right, now this is just going to be a giant quadratic equation. We just need to simplify it, okay? So expand first. 3y squared plus 2y minus 21. Notice how I keep everything in a bracket, okay, in brackets. So the negative sign won't mess me up. Okay, so minus 16 minus y squared minus y minus 6 equals 0. Oh, this one is not too bad, because you have 3y squared minus 2y squared minus 1y squared. Actually, the y squared cancels out. This is going to be a linear equation. Okay, now we collect the y terms. So that's 2y minus 4y, that's negative 2y. And we have negative 2y minus negative y, that's plus y. So negative 2 plus 1 is negative y. We have negative 21 minus negative 16, so that's plus 16. Negative 21 plus 16 is negative 5. And we have negative 5 minus negative 6. Again, minus is a plus. So we have negative 5 plus 6, which is positive 1. Okay, we can solve for y by moving y over. You get y equals to 1. Now, we check the restriction, okay? So y, if you go back to this line here, you can see y cannot equal to 3, y cannot equal to 2, and y cannot equal to negative 3. Also plus minus 3 is okay. I'll just write it like that. 1 is not one of them. So 1 is our answer. Okay? Not too bad, right? Again, you will need to factor a lot. As you can see, you need to multiply a lot. So that means you're actually doing a lot of algebra. Okay? So you need to really be really careful with your work, because one little mistake, it's going to lead to the wrong answer. Okay, so make sure you do your work slowly. Okay, all right, that's it for solving rational equations. Again, here are the steps if you need to review. Otherwise, you can do some practice questions now. Okay, good luck.